Okay, so today we're going to do 4.8 day 2. I'm also going to call it an inquiry lab. So, name and date up at the top. We're going to explore how our families of nonlinear functions, the same as their parent functions, how are families of nonlinear functions different from their parent functions. So we're going to talk about what a parent function is here on slide 2. It says family of nonlinear functions, so things that aren't lines, share a common characteristic based on a parent function. The parent function, or simplest function, of a family of quadratic functions is y equals x squared. So everything stems from that, basically. They're saying that's the parent. Its children look like that, but have some kind of modification. You can use a graphing calculator to investigate the families of quadratic functions. So we're going to graph these 3 functions on slide 3, but first let's get some values. So if we plug in -1, 0, 1, and 2 for all 3 of these functions, and then we'll graph them all on slide 3. So -2 squared is 4, -1 squared is 1, 0 squared, 1 squared, and 2 squared. Okay, now this one says it's x squared plus 5. So -2 squared plus 5. So 4 plus 5 is 9. -1 squared plus 5, 1 plus 5 is 6. 0 squared plus 5 is 5. And then we've learned already that the pattern follows. It's the top half and the bottom half are the same thing. We try this one, -2 squared minus 3. So this would be 4 minus 3 is 1. -1 squared, or 1 minus 3 is -2. 0 minus 3 is -3. And then following the pattern. So we're going to graph these. I'm going to use hopefully different colors. If not, I'll just highlight one. So this x squared I'm going to do in blue. The x squared plus 5 I'll do in purple. And then the last one I'll just highlight with my highlighter. That's all I have here. Okay, so x squared is -2 and 4, -1 and 1, 0, 0, and then the same on the other side. So a nice kind of curve upward since it's a positive x. The next one, x squared plus 5, is -2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So same thing on the other side. -1, 6. 8, 7, 6. And then 0, 5. So it looks the same shape as x squared, but had a plus 5 attached to it. So the -3 is -2. Ooh, -2. Oh, doing that in this highlighter. -2, 1. -2, 1. -1, -2. 0, -3. There we go. Attaching those. They'll look almost the same shape, but have different situations, spots, locations. How are these equations related? Well, they all have x squared in them. So that's the parent functions. Describe how the graphs of these 3 equations are related. The graphs are the same, but they are shifted, so they're up or down, but shifted up or down the y-axis. Okay, let's flip it over here to slide 5. An exponential function is a nonlinear function in which the base of a constant and the exponent is an independent variable x. You might want to check to see if that's a vocabulary on your sheet. The parent function for an exponential function is shown. So the base of 2, 2, and x. Or the base is a constant. So it could be y equals 3 to the x. That could be another parent function with a base of 3. We're going to use the Desmos app on your iPad to do our next investigation. So I'm going to have this here, but I also have my iPad opened up on the Desmos. So I'm going to have to slide this over so that you can see this screen. Oh, and hopefully it'll come into focus. Well, if If not, just follow the directions as closely as you can. Okay, so it says, open the Desmos app, type in, so it says a certain type of bacteria doubles every hour. The function y equals 2 to the x represents the total number of bacteria y at the end of every hour x. So x, we would plug in our hours there. Graph the function, then find the number of bacteria at the end of 5 hours. So it says, open the Desmos app, type in y equals, then the 2, then the a squared button, delete twice, backspace twice, and then push X. And you should see it. Shows up there. You can see it like it looks like that on yours. Roughly copy your calculator onto the blank screen shown. Describe the function analyzing the graph. So I'm going to switch. So if I wanted to roughly draw what is on my iPad, I see that it like hugs the y-axis and goes to the point 0, 1, so trying to do that. And I can see that it goes to the point 1, 2. So just 2 points to help me guide my curve, and then it goes up. So describe the function by analyzing the graph. So it's a positive growth, hugs the x-axis. I'd say this, yeah, positive growth. If I had to talk about slope, it would be positive. But let's go and look at slide 7. Ask us some questions here. Using slide 6 graph, or what's on your calculator, Desmos, press the gear above where you typed in the equation. Press this gear. Okay, then it says, inside the equation box, picture that looks like a table. So did that. What output value is true when x equals -2? So that would be 0.25. So no F2, if we're thinking about this in time, -2 hours, which doesn't really exist. There isn't even a whole bacteria there. Under the x column, replace 2 with 5. What value, oh, if you can see it, what value do you get? I replaced it, I got 32. So 32. Try again with an x value of 10. So you can delete your 5 and put a 10 in there. And I got a 1024. So what does this mean? So there are 32 bacteria at the end of 5 hours and 1024 at the end of 10 hours. So you're going to use this Desmos app and to discover some things about these parent functions of exponential functions and to discover some things about parabolic functions. So you will see some of those on your homework. You'll have to use this information in order to type in new types of equations. You can use different colors on your homework to graph 3 different things in the same one. It's spelled out pretty clear for you. 10 things that require 0 talent but can still lead to success. Be on time, making a big effort, improve your health and energy, have a positive attitude, live with passion, use powerful body language, be willing to learn, go the extra mile, be prepared for anything, and have a strong work ethic. Have a great day.